Good morning, everyone. So today we will discuss about Lensmaker's formula, okay, and its derivation. This is Lensmaker's formula, and also here we are going to derive the equation. Clear? So Lensmaker's formula, it is basically the relation between the focal length of a lens along with refractive index and radius of curvature, okay, for the two spherical surfaces. Clear? So here this is the formula, isn't it, which we are going to derive. So here, suppose if we take this is one lens. So for this lens, it will have a particular focal length, okay, that we have considered as f, and it is also having a refractive index with respect to the surrounding medium. Here we have considered as mu, okay, and for the two spherical surfaces, okay, they have radius of curvature r1 and r2. Clear? So this is the Lensmaker's formula, where the focal length of the lens, it is related with the refractive index of the lens material along with the radius of curvature for the two spherical surfaces. Okay? So here we are going to derive the formula. Okay? So for derivation, the derivation of Lensmaker's formula, so for this, if we consider, suppose here this is one convex lens, okay, and one object, it is point object, which is lying on the principal axis or optical axis, okay, and this lens, it is having two spherical surface. One is A, B, C. Second surface we have considered as A, D, C. Okay. Now here if we consider one incident ray, that is striking the first surface at point M. Clear? Now you see, for the first spherical surface, so it will have center of curvature in this direction, isn't it? Okay? So if we join the point along with the center of curvature, so that will be the normal at this surface. Okay? Then accordingly, the ray which is after refraction, it is bending towards the normal. Okay, like this, isn't it? Because here generally the surrounding medium, which is considered as rarer medium with refractive index mu1, okay, and the lens material, that is optically denser, isn't it? And it is having a refractive index mu2. Okay? So this is having a denser medium. Clear? Now, here is say after refraction from the first spherical surface, Okay, the ray it will move in this direction. So here you get the first image, that is suppose I1, and it is formed by the first surface. Clear? Now this image which is formed by the first spherical surface, now it will behave as a virtual object, okay, for the second surface. So accordingly we can get the final image due to refraction by the second spherical surface. Okay, here you see this is the direction of the refracted ray after reflection from the first surface. Then again it is striking the second surface, isn't it? Here we have considered this is the direction of the refracted ray. Okay, but actually what happens here after refraction by the second surface, so this ray it will further deviate, isn't it, which will be away from the normal. Now for the second surface, center of curvature will be in this side. Okay, clear? So after refraction, the final ray it will bend away from the normal. Means it will move like this, in this direction. So here we'll get the final image I. Clear? So again I am repeating the figure. Here we have considered one lens which is bounded by two spherical surfaces ABC and ADC. Okay. Now light ray due to point object O, that is lying on the principal axis or optical axis, and the ray we have considered as OM for the first surface. Then after refraction, if we consider suppose here second surface is not there, okay, then after refraction we will get the first image I1, isn't it, due to the first surface. Okay, and since here second refracting surface is also there, so this refracted ray again it will strike the second surface. Okay, so final image will be formed due to refraction by the second surface. Okay, and here I is the final image after refraction by the second spherical surface. Clear? Now we have already got the curvature equation for the two spherical surfaces, convex and concave surfaces, isn't it? So here also we can find or we can get the curvature equation for the two surfaces. Okay, after that I can combine the two equations. Okay, then finally we can get the lens maker's formula. Okay, clear? So now here we will consider the curvature equation separately for the two spherical surface. Okay, first if we consider for surface that is ABC. Okay, clear? So here you see for the first surface your ray diagram will be like this. The first surface, it is a convex surface, that is ABC. So this is the optical axis. So here this is the point object O. Now if we consider this medium, isn't it, that is on left of the surface. So this is radar medium with refractive index mu1, and the medium which is on right of the surface, it is denser with refractive index mu2. Clear? Then the incident ray which you have considered as OM, Okay, after refraction, what will happen? For this convex spherical surface, so this is the position for center of curvature. Then if we join these 2 points, isn't it? M with C. Okay, then this will be the direction of normal, isn't it? So this will become normal, okay, at point M. So after refraction, since it is moving from rarer to denser, isn't it? So after refraction, the ray it will bend towards the normal, like this, isn't it? So this will be the refracted ray due to the first spherical surface. Clear? So here we get the first image, which we have considered as I1 for the first surface. Okay. Now this will be the angle of incidence, and this will be the angle of refraction, isn't it? Okay. And these angles, this we have considered as alpha, this is beta, and this is gamma. Clear? This is beta, this is gamma, and this is R. Now you see, by using Snell's law, isn't it? Here you can write using Snell's law of refraction, and when these angles, the angle of incidence and angle of refraction, they are small, okay, then we can write mu1 into I mu2 R. Okay, this is the equation number 1, and this equation we can write for a small value of I and R. Okay, again you see from this triangle, that is OMC, here I we can write alpha plus gamma, isn't it? This is gamma. Okay, so here I we can write, which will be alpha plus gamma, okay, from triangle, that is OMC, and R we can write, R will be from triangle MC I1, isn't it? Which will be gamma minus beta. Okay, this is from triangle MC I1. Clear? Again, here for smaller aperture, isn't it? This MB almost we can consider as perpendicular. Okay, okay. This MB for smaller aperture of the surface, so we can almost consider as perpendicular on the optical axis. Clear? Then you see from this triangle, for small value of alpha, isn't it? We can write MB by OB. Okay? So here you see for a small value of alpha, beta, and gamma. Okay? You see from this triangle, that is MBO, tan alpha will be MB by OB, isn't it? And for small value of alpha, okay, so tan alpha we can write, this is almost equal to alpha, which will be from this triangle, it will be MB by OB. Clear? Similarly, we can write tan beta, which is almost equal to beta. It is from this triangle, that is MBI1, isn't it? So this will become MB by BI1. Okay? Similarly, we get 10 gamma. This is almost equal to gamma, isn't it? For small value of alpha, beta, and gamma. And this value we'll get from this triangle MBC. Okay? So this will be MB by BC. Clear? So therefore, these equations, isn't it? We can write, if we replace alpha and gamma by this ratio. Okay? So this will become MB by OB plus MB by BC. Similarly, your equation R, it will become, R will be from these two values, isn't it? Gamma minus beta. So it is MB by BC, okay, minus MB by BI1. Clear? Now you see, we can substitute these values, isn't it? This I and R, okay, in equation 1. Okay, so after this, after substituting the values of I and R, isn't it, from these two equations into equation 1. Okay, so therefore your equation 1 implies this is mu1. Now I we can replace by this, which is MB by OB plus MB by BC, isn't it? And this is mu2. R it is MB by BC minus MB by BI1. Okay? Again, here you see MB we can take common, isn't it, on both sides. So after that we can cancel it. Okay? So this equation will become the mu1 by OB plus mu1 by BC, and the right hand side, this is mu2 by BC minus mu2 by BI1. Okay? Clear? Mu2 by BI1. Again, we can write, here you see this BC is common, isn't it? So we can take in one side, then this will become mu1 by OB. Now this time you bring to the left hand side, okay, this is plus mu2 by BI1. Now this time you bring to the right hand side. For this 2 we can write mu2 minus mu1 by BC. Okay, so this is the equation number 1. Clear? Now again, if we consider the refraction for the second surface, okay, again you can write for surface, that is ADC. Okay, so you see for this surface, that is ADC. Now light, it is traveling from denser to rarer, isn't it? Okay, so here it will be like this. So this is your A, D, C, okay, and this is the principal axis. Now you have seen in the first figure that the incident ray, it was like this now for the whole lens. So this was the refracted ray, okay, for the first surface, and again we have got the final refraction in it due to the second surface like this, okay. So this was the first image. Now this will be the final image, okay, clear. So for this second surface, you see the incident light, it will be in this direction, isn't it? Which is the refracted ray for the first surface. Okay. So for the second surface, your incident ray, it will be directed like this. Clear? Okay. So this point is M. Then again, if we join the point along with the center of curvature, okay, then we'll get the normal, okay, this point is M. Then this is the angle of incident I. Now you see this side is denser medium with refractive index mu2, and this side is rarer medium with refractive index mu1. Okay, clear? So after refraction, isn't it? Now what will happen? Since it is moving from denser to rarer, okay, denser to rarer medium. So after refraction, now bending will be away from the normal, isn't it? So this is the initial direction. Okay, where we have got the first image I1, but now it will not move in this direction, isn't it? So it will bend away from the normal. Okay, so we get the final image, which is I at this position. Clear? Now this is the direction of refracted ray. So this will be the angle of refraction R. Clear? So again, now I1, it will behave like an object, isn't it? Virtual object for the surface. So this angle we have considered as alpha, okay? And I is the final image. So this angle is beta, and C is the center of curvature, isn't it? So this angle we have considered as gamma. Okay? So for this surface, isn't it? So we can also write here also for this surface, you are using Snell's equation, isn't it? तो ये हो जाएगा mu 2i, which will be equal to mu 1 r. Okay. Again, you see from this triangle, that is M, C, and I1, isn't it? So M, C, I1. So for this triangle MCI1, I is the exterior angle, isn't it? Which will be equal to gamma plus alpha. Okay. So here we can write I will be equal to क्या हो जाएगा gamma plus beta. Again you see for small value of alpha, beta, gamma, and again due to smaller aperture of the surface, तो हम लोग MD almost यहाँ पे परपेंडिकुलर कंसिडर कर सकता है, ठीक है. Then accordingly from this triangle MCD, okay, so we'll get gamma will be MD by CD, isn't it? And from this triangle MI1D, alpha will be, for small value of alpha, MD by DI1, okay. Again for small value of beta, so it will be MD by DI, okay. So this we can also write gamma will be MD by CD, isn't it? Plus beta will be MD by DI. Clear? Similarly, R will be the angular refraction. You see from this triangle MCI, so you can write this will be gamma, okay. Sorry, this is not beta, this is alpha, okay. Clear? So this is the I1. I, it is alpha plus gamma, okay. MD by CD plus MD by DI1. Then from this triangle, that is MCI, okay. So R will be gamma plus beta, isn't it? Gamma plus beta. So it will be again MD by CD, and beta will be MD by DI. Clear? Understood? Here I from the triangle MCI1 we can write gamma plus alpha. Again for small value of gamma and alpha, we can replace the angles in terms of the ratio of the sides, isn't it? Which should be MD by CD, that is the value of gamma if it is very small, and for alpha it will be MD by DI1, okay. And similarly beta will be MD by DI, and again gamma and beta, isn't it? These are the two opposite interior angle for angle of refraction R, okay. And gamma and alpha are the two opposite interior angles for the angle of incident I. So accordingly we can write these equations, okay. Then this equation, isn't it? We can also write mu2. Now you can replace the values. This is MD by CD plus MD by DI1, okay. Mu1, then R we can replace by this MD by CD plus MD by DI, okay. Again here you see MD, here we can take common, isn't it? After that we can cancel on both sides, okay. So this will become mu2 by CD plus mu2 by DI1, okay. And on the right hand side this is mu1 by CD plus mu1 by DI, okay. Now you bring this term, okay, to the right hand side, and this term, that is mu1 by CD, to the left hand side, Okay, so you can write, if we bring this term to the right hand side, that is mu 1 by di minus mu 2 by di1. Okay, clear? Or you can also write like this. This is mu 2 minus mu 1 by CD, isn't it? And in right side is mu 1 by di minus mu 2 by di1. Okay? Or you can also write, finally, the equation will be after this, okay, it will be mu 1 by di minus mu 2 by di1 will be equal to mu 2 minus mu 1 by CD. Clear? Now, here see, if the length it is very thin length, okay, we have considered the first surface like this ABC, and second surface we have considered as ADC. Okay, now if the length it is very thin length, then B and D, these 2 points almost we can consider close to each other. Okay, so if they are close to each other, isn't it, then di1 we can replace by, almost it will be equal to bi1, isn't it? Okay, so for thin lengths, okay, so di I1, this is almost equal to bi1. So therefore, this equation, now for the second surface, we can also write mu 1 by di. Now di1 we can replace by bi1, isn't it? This is mu 2 minus mu 1 by CD. Okay, so here you see, this was the first equation for the first surface. Now this is the second equation for the second spherical surface. Okay, now if we add the two equations, okay, by adding equation 1 and 2, so we get like this. Now you see, this was the equation for the first spherical surface, isn't it? That was convex. And equation number 2, this is for the second spherical surface, isn't it? Which is the concave surface. Okay. Now combining these two equations, isn't it? We'll get the whole formula, isn't it, for the length. Okay. So it will be now adding equations 1 and 2. So here you see, if we add the two equations, isn't it, then these two terms, they will cancel out, isn't it? Because here it is negative, here it is positive. Okay. So final equation will be mu 1 by di, okay, plus mu 1 by OB. Okay, then from these two terms, mu 2 minus mu 1, we can take common Clear? Then this will be 1 by BC minus 1 by, plus 1 by CD. Clear? Again, here is C. Now, according to sign convention, okay, so we have considered O as a point object, isn't it? So OB, it will be the object distance, okay. I is the final image, so DI will be the final image distance, isn't it? Again, BC is the radius of curvature for the first surface, CD is the radius of curvature for the second surface, okay. So here, according to sign convention, your OB will be, you can again see the figures, isn't it? You can get OB, it will be minus U, okay, and DI, this is plus V, BC, that is radius of curvature for the first surface, which will be positive, and CD, that is the radius of curvature for the second surface, isn't it? And this will be negative. Okay? So therefore, now this equation, okay, तब इसका हमको second form क्या मिलेगा? We can also write, so this will become mu 1 by di, मतलब v हो जाएगा, ठीक है, OB मतलब minus here, isn't it? So this will become negative, okay, and the right hand side, this is mu 2 minus mu 1, clear, multiplied by 1 by R1 minus 1 by R2, okay. Again, this mu 1, isn't it? We can take common on the left hand side, isn't it? After that, we can bring to the right hand side, okay. So it will be 1 by V minus 1 by U. Mu 1 you take common, after that you bring the term mu 1 to the right hand side. So this will become mu 2 minus mu 1 by mu 1, okay, multiplied by 1 by R1 minus 1 by R2, clear. Again, here you see, on the right hand side, we can divide by mu 1, isn't it, separately, okay, for these two terms, isn't it, mu 2 and mu 1, okay. So it will become 1 by V, then this is mu 2 by mu 1, isn't it, minus 1, okay, into 1 by R1 minus 1 by R2, clear, okay, okay. Then here you see, here U is the object distance and accordingly V is the image distance, okay. Now if we consider when the object at infinity, okay, that means when the object is placed at infinite distance from the lens, okay, then your image, it will form at focus, isn't it? Then your V will become F, okay. Again, is mu2 by mu1, isn't it? This is the refractive index of second medium. Here it is lens medium with respect to the first medium. Okay, first medium means the surrounding medium of the lens. Okay, so therefore finally your equation will become like this. Your final equation will be like this. Here if we replace u by infinity, isn't it? 1 by infinite, it will become 0, and f it will become in place of v, isn't it? It is 1 by f, which will be equal to mu 2 1 minus 1 into 1 by r1 minus 1 by r2. Okay, or you can also write this means refractive index of lens material with respect to the surrounding medium, isn't it? Minus 1 into 1 by r1 minus 1 by r2. Okay, so this is the required lens maker's formula. Okay, here this mu ls, so this is the refractive index of lens with respect to the surrounding medium. Okay, so this is the lens maker's formula which we can derive by considering the refraction for the two spherical surfaces. Okay, clear? Okay, thank you. I think all of you have understood the topic, isn't it? Okay, bye, thank you.